All right, let's get started this morning after the keynote. First up in this room is Trey Hanna. Trey is a Python and Django coach, teacher, mentor, and comes from San Diego, so long flight over here. He's a director of the Python Software Foundation, board member of the member of the Django Software Foundation, and heavily involved in the local user groups back home. He gives training sessions for Django and Python, like apparently all day, like during the day for commercial reason on in corporate environments, and during nights for free in live broadcasts. So he's going to talk to us about comprehensible comprehensions, and yeah, let's give him a round of applause.
Thanks, Marcus. So I'd like to share with you my love of a particular Python feature that is often misunderstood and misused. So this is pretty much everything Marcus just said. My name is Trey. I help Django teams onboard new teammates and turn their front-end developers into full-stack Django developers. I also host a free live webcast every week on Python-related topics. I do usually host them at 3 a.m. Australia Eastern Standard Time, so sorry. There are recordings online, though. You can watch them after the fact, and you can ask questions beforehand, and I'll be happy to answer, even though you're not there. So I'm also one of the co-organizers of my local Python meetup in San Diego, and I've helped co-organize 4 Django Girls workshops in the Southern California area. I'm also one of the 13 directors of the Python Software Foundation. All right, so that's enough about me. Let's talk about some assumptions that I am making during this talk. So during this talk, I'm assuming that you already know how for loops work in Python. I am also assuming that you are not already a fan of list comprehensions. But I hope that by the end of this talk, you will be a fan of list comprehensions. So let's define some of the words that I'm going to be using during this talk. An iterable is anything that you can iterate over. So anything that you can loop over with a for loop in Python is an iterable. Lists are iterables, dictionaries are iterables, sets are iterables. Lots of things in Python are iterables. A list comprehension is a special syntax for making a new list. A generator is a lazy iterable. Generators pause and restart themselves repeatedly as you loop over them. And generator expressions are a special syntax for making a generator. So I'll be using all of those terms during this talk, but the term that we are primarily focused on is list comprehensions. List comprehensions do not solve a new problem. List comprehensions don't solve a new problem. They are simply a special purpose tool for solving a problem that we can already solve with for loops. That problem is turning one list into another list, or more generally, transforming an old iterable into a new iterable. So list comprehensions do not solve a new problem. They're simply a special purpose tool for solving an existing problem. Let's talk about for loops. Python's for allows us to loop over an iterable and do things with each item in that iterable as we loop. We can put if statements, print functions, and pretty much anything that we want inside of a for loop. We can put anything we want in the body of that for loop. This for loop makes a new list. Making one list from another list is a really common thing to do in Python. It is more common than in most other programming languages. It is common in other programming languages, but it is much more common in Python. Why is making a new list from an old list so common in Python in particular? So I'm going to take a little aside here to talk about the reason that we tend to turn old lists into new lists so often in Python. So assigning to a variable in Python does not copy anything. Variables in Python are not buckets that contain things. That mental model of the world works in some programming languages. It breaks down very quickly in Python. Variables in Python are simply references to objects. This can really trip up new Python programmers. So we tend to copy old lists to new lists because mutating lists is often a bad idea in Python. When we copy a list, every other variable, when we modify a list, every other variable that points to that same list will also be updated. Variables are simply references. They are not buckets that contain things. So this fact here is the underlying reason that we find list comprehensions useful, or rather it's the underlying reason that we tend to convert old lists to new lists so often in Python. All right, so that's a little background for why we have these things. Turning old list into new list is very common to do. It is such a common thing to do that this for loop here, there's a special syntax for this called a list comprehension. This list comprehension is equivalent to that for loop that we just wrote. This is a very information-dense thing, though. That for loop had 4 lines of code. This is 1 line of code. Let's break down our for loop and break down this comprehension and compare these two. So I've highlighted in our for loop here 5 things. I've highlighted the variable name of our new list, that's in green. These square brackets that make our list a list are in a kind of dark red color there. The looping logic is in purple. The condition is in bright red. And the thing that we're appending every time is in blue. These are the same items highlighted in our list comprehension. Notice that our comprehension contains pretty much the same information as our for loop. The only things that are missing are that we are not repeating a variable name, and we don't have an append. There's no call to append there. Loops and list comprehensions are so similar that you can actually copy-paste your way from a for loop into a comprehension. So to copy-paste your way from a for loop into a list comprehension, the first thing that we need to copy is the new list. The next thing that we need to copy is the item that we're appending. Then we copy the looping logic. And the last thing we need to copy is the condition that we're checking every time that we loop. After that, we've copy-pasted our way from a for loop to a list comprehension. So copy-pasting away from a loop to a list comprehension means that we don't have to write anything new. We can take something that we already understand and rejigger it into something that is new to us, a list comprehension. So I've highlighted here the same 5 things that I was highlighting before, but this is kind of generic code. It's a blueprint of sorts. As long as you can figure out how to write your code in this format, you can always copy-paste your way from a for loop to a list comprehension. So I've shown you how to build a list comprehension from a for loop. Let's talk about readability. The most common complaint that I hear about list comprehensions is that they are hard to read. List comprehensions take perfectly readable for loops and make them completely unreadable. The main reason behind this complaint is that list comprehensions tend to be much more compact than for loops. Comprehensions are often written all on 1 line of code. That is what makes comprehensions hard to read. The comprehension here has less unnecessary information than the for loop here, but it also has less white space. The for loop that we've written has white space in it because Python forces us to indent our for loops. We can't write a for loop all on 1 line of code, at least not like this. Python forces us to put line breaks in our code and to use indentation to space out our code. Python does not force us to put any spaces at all in our comprehension, and we've chosen not to for some reason here. Comprehensions have 3 parts: the operation, the loop, and the condition. There is no reason that all 3 of those parts have to be written on 1 line of code. In Python, whenever you have an open square bracket, an open curly brace, or an open parenthesis, you can insert line breaks to break 1 line of code into multiple lines of code. Breaking comprehensions over multiple lines can make them much more readable. In fact, I would argue that breaking up a comprehension over multiple lines almost always improves readability. And because of that, I would recommend that if you're about to write a comprehension, you start by writing it over multiple lines, and you only compact it into 1 line if that actually makes it more readable. Embrace white space. White space is your friend. Note that this multi-line list comprehension has not saved us any lines of code. In fact, we had 4 lines of code. We now have 5 lines of code. list comprehensions are not about saving lines of code. List comprehensions are about making our code more descriptive and more readable. When a reader looks at that for loop, it's obvious that we're looping, but it may not be immediately obvious why we're looping. When a reader sees that comprehension, it should be immediately obvious that we're creating one list from another. That is the only thing that list comprehensions are for. When we use a list comprehension, we're being more specific about the intent of our code. Our code is making one list from another list. We're not just looping. All right, so I've glossed over a few important details about the way that list comprehensions work. Or rather, some important details about the way that you can use list comprehensions. So let's take a look at a few other ways that we can use comprehensions. So this whole time, I've been showing you list comprehensions with a condition. These comprehensions filter out items that don't match a certain condition. We can also write list comprehensions that don't have a condition. Here, we're not filtering down our list at all. We're simply changing each item as we add it to a new list. So our for loop here doesn't have an if statement, and our list comprehension doesn't have any condition. List comprehensions can be used for filtering, they can be used for mapping, or they can be used for both. We were using them for both before. Here, we're only using them for mapping, taking one list, changing each item in it when we make up a new list. You can also put multiple for loops in a comprehension. Here, we're looping into a list of lists and flattening it into a single list. Now, putting multiple for clauses in a comprehension can get a little bit complicated, so be careful about using this. And if you're going to do this, make sure that you break up your comprehensions over multiple lines. Never write one line of code that has two for loops inside it. That is not readable. Comprehensions aren't just limited to lists. In Python, we also have set comprehensions. Just like list comprehensions build up new lists, set comprehensions build up new sets. So this for loop here, we're adding to this set every time. In the list comprehension, it also adds to this set every time. The same way that or in the set comprehension here, sorry, the same way that a list comprehension would append to a new list every time. There's also dictionary comprehensions, which you probably see a little bit more often than set comprehensions. Notice that the same way that dictionaries use curly braces and sets use curly braces, both dictionary comprehensions and set comprehensions use curly braces. The thing that distinguishes them is the colon. Unlike list comprehensions, I always break my dictionary comprehensions over multiple lines. I don't like to see that colon on the same line as that for. I find it unreadable personally. All right, so that's a couple different flavors of comprehensions there. Let's take a look at some examples of these. So I'm going to go through these quickly for the sake of time, but you can review these slides later on your own. One of the simplest uses of list comprehensions is to make a new list from an old list without filtering it at all, maybe slightly modifying each element as we go. Here we're lowercasing each word in a list of words. So fairly simple list comprehension here. This is a very common use case. Slightly more complicated use case. Here we're using a comprehension to loop through words and check whether each word is an anagram of a particular word, of a target word. Note that we're calling a function to do this. The function is called isAnagram. The reason I didn't stick sorted word 1 equals sorted word 2 is because it's not obvious what that is. That isAnagram function describes the action that we're doing each time. So we're using a function to make our code a little bit more descriptive, which is fairly important to do with comprehensions. It's also important to do with for loops, though. So we're using a list comprehension here to filter down our list, whereas before we were simply changing each item. All right, this is not a comprehension. This is a for loop with another for loop inside it. We are building up a list of lists. That inner for loop looks like comprehension material, though. We've got a new list that's being made, new row, and we're appending to new row every time we loop. We could turn that into a comprehension. Now we could stop here, but you might notice that we still have something that looks like comprehension material. We have a new list, negative matrix, and we are appending to that list every time. So we could copy-paste our way into another comprehension. Now we have a comprehension inside of a comprehension. Please only do this sparingly. Comprehensions inside of comprehensions do not always improve readability. In fact, I would think that they probably mostly do not improve readability. I would argue, though, that in this particular case, I find that last block of code more readable than that first block, personally. But that's up to you. List comprehensions make lists. Set comprehensions make sets. Dictionary comprehensions make dictionaries. Generator comprehensions make generators. Except that they're not called generator comprehensions. They're called generator expressions. Why they're called generator expressions, I don't know, but that's what they're called. So if you call them generator comprehensions, people are going to know what you're talking about, or at least I'll know what you're talking about, but they are technically called generator expressions. So you might be wondering what a generator is. I am not going to go too deep into what generators are during this talk, because that could take up a whole talk of its own. There is one thing that I want you to remember about generator expressions, though. If you are writing a list comprehension and you're only going to loop over the list that you make once, you should write a generator expression instead. So I'm going to say that again. If you're making a list comprehension and you're only going to loop over your list once and only once, use a generator expression instead of a list comprehension. All right, let's look at how list comprehensions work. So if you write a list comprehension and you change the square brackets into parentheses, you've made a generator expression. Generator expressions make generators the same way that list comprehensions make lists. Generators are pretty weird, though. Generators don't know how many elements are inside them, so they have no length. And you can't index a generator like you can with a list or with a tuple. The only thing that you can do with generators is loop over them. And if we loop over a generator a second time, we'll get nothing back. So generators are a little bit weird. This generator is squaring all numbers from 0 to 1 billion. That would take a very long time and could fill up my computer's memory. But this generator hasn't actually done any work at this point. Not until we start looping over it. Generators compute items as they go. So at this point, this generator has only computed the first 3 items. Generators can be looped over, just like lists, but they are lazy. They only compute items just before you ask for them. So generators are lazy. Generators are also one-time use only. The only thing you can do with generators is loop over them, but only once. The second time you loop over a generator, it's empty. Generators are one-time use only. Once you've fully looped over a generator, we say that it is exhausted. This generator has been exhausted. So generators are lazy and they are single use. So to be on the safe side, when you are using a generator, you should loop over that generator as soon as humanly possible. Don't even make a variable to store it if you don't need to. Just loop. The sooner you loop over a generator, the less likely it is that you might accidentally loop over it 2 times. So this is such a common thing to do in Python, taking a generator expression, passing it straight into a function. There's actually a special syntax for this. You're allowed to remove those redundant parentheses around generators. They were designed for this purpose. This is probably actually the most common way to use generators in Python. Create it and loop over it right away. All right, so I'm pretty sure most of you are probably still a little bit fuzzy on how generators work and what they are. You can look those up later. But I want you to understand or remember that if you have a list comprehension and you're only going to loop over that list once, that's when you should turn it into a generator expression. Let's take a look at a few examples. I'll be going through these quickly as well for the sake of time, but you can look into these on your own later. So here we are looping over a list of words. We're looping over a list of words that we split from a sentence, and we are transforming them and then adding them to a new list. After that, we are joining them together with spaces. So we've got a lot of code, or a lot going on in very few lines of code here. We could turn that loop part into a comprehension. We could copy paste our way from that loop into a list comprehension. But we could also take this a step further. We could inline that list comprehension into that call to the string join method. And then at that point, since we're only looping over it once, we could turn it into a generator expression by removing those square brackets. So here we've moved our list comprehension into the join method, and we've removed those square brackets to make it into a generator expression. Personally, I find that last block of code more readable than that first block. These do take a little bit of getting used to, though. If you ask a new programmer what these blocks of code do, well, you might be surprised. They might find that last one more readable. Here we're looping over numbers and summing up their squares. This is not comprehension material, but this would be. So this is a little bit odd what we just did. We are building up a new list just to loop over it once using the sum function. The reason we did this is because this allows us to copy paste our way into a list comprehension and remove those square brackets to make a generator expression. So personally, I find this generator expression more descriptive than the code that we started with. It pretty clearly says that we are summing up the squares of each number. It looks a little bit more like math than like code, in my opinion. So we've looked at comprehensions, and we've looked at generator expressions, and we've seen how to copy-paste our for loops into comprehensions. But when exactly should you use comprehensions? And is there ever an inappropriate time to use them? Is it ever a bad idea to use comprehensions, or should you just turn all of your for loops into comprehensions? List comprehensions are only useful for turning one list into another. Do not use comprehensions except for making lists. Comprehensions should only be used for the specific but very common use case of turning one list into another list. Here we are calling the print function in a comprehension. We ended up creating a list of none values, and we printed things out. We really didn't care about those none values at all. We didn't want a list of none values. The thing that we cared about was the side effect. We cared about the printing. Do not call print in a comprehension. In fact, don't put any side effects at all in your comprehensions. Comprehensions are not meant for side effects. They're meant for building up new lists. List comprehensions should only be used for turning one list into another list. Here we're looping over a list of tuples and making a dictionary out of them. You might think that this would be a great opportunity to use a list comprehension. But this isn't the best way to turn a list of tuples into a dictionary. What is the Pythonic way to turn a list of tuples into a dictionary? I'm sure some of you know this. I hear it being whispered. It's the dict constructor. The dict constructor is specially designed for exactly this task. There is no reason to reinvent the wheel by doing this ourselves manually. Here we are looping over lines in a file, and we are putting them into a new list. Whenever you see a comprehension that does no filtering and no modification at all, that should be a red flag. This list comprehension does exactly that. We are not filtering, we're not modifying. The list constructor is specially made for this use case. This is the Pythonic way to take one list and make a new list out of it, or to take one iterable and turn it into a list, which is what we're doing in this case here. You don't need to make a comprehension when you're not changing anything and you're not filtering anything. Okay, so I do want to note here that files also have a readlines method. You could use this instead. Depending on who you ask, they'll say that one of these is more Pythonic than the other. You'll probably get a different answer depending on who you're asking. At the moment, I prefer that middle one, though I could probably be convinced that the last one is more Pythonic, so sometimes there's multiple ways to do it. The point here is that Just as there are sometimes simpler ways to do things in a for loop, for example, a comprehension, there are also sometimes simpler ways to do things in a comprehension. For example, the list constructor. Okay, I have a little visual review here of everything that we've just gone through. I hope that these slides can act as a cheat sheet of sorts to help you figure out when, how, and where to use comprehensions and generated expressions in your code. I'm going to run through these quickly, but you can review them later. This is a for loop that loops over a list of items, does an operation, and appends the result to a new list. Whenever you have a for loop written in this format, you can always copy-paste your way into a comprehension. This list comprehension is equivalent to that for loop. This for loop is the same as before, except that we're checking a condition to filter our new list as we build it up. Whenever you have a list comprehension in this, or whenever you have a for loop written in this format, you can also copy-paste your way into a list comprehension. So before we were not filtering, now we're filtering, same thing. We can always copy-paste our way into this. This one's a little different. This is a loop that checks a condition and builds up a new dictionary of key value pairs. This loop is equivalent to this comprehension. You can almost copy-paste your way into this. That colon is a little bit different, but it gets you most of the way there. This is a nested for loop that builds up a new list. We're taking a list of lists and converting it to a flattened list. Whenever you have code in this format, you can copy-paste your way into a comprehension. This list comprehension is equivalent to that for loop. Do note that the order of those for clauses does matter, though. This doesn't read like human English, so I'd actually recommend always copy-pasting your way into a list comprehension, because you won't get tripped up that way. If you're making a new list from an old list without filtering or changing anything at all, you should not use a list comprehension. You should use the list constructor. The list constructor loops over whatever we give to it and builds up a new list. It's simplistic, but sometimes the simple thing is all that we need. If you're making a list and immediately looping over it, you should consider copy-pasting your way into a generator expression. Generator expressions look like list comprehensions, but they're lazy. They don't do any work until we start looping over them. So we're getting the benefit here of not having to create an unnecessary list just to loop over it one time. I want you to remember that you can use list comprehensions for looping over an iterable and building up a new list from it. You can use set and dictionary comprehensions for taking an old iterable and turning it into a new set or a new dictionary. And if you have a for loop that is written in the right format, you can always copy-paste your way from a for loop to a comprehension. Also, if you ever find yourself making a list just to loop over it one time, instead of using a list comprehension, use a generator expression, or turn your list comprehension into a generator expression by removing those square brackets. And also, please remember to break your comprehensions over multiple lines to improve the readability of your code. If you're using this construct, don't make your code unreadable. So the last thing I have for you is a list of semi-related talks and articles that you can look up later. Thank you.
Thanks, Trey. As a token of appreciation, we have this long-standing tradition of a coffee mug.
Thank you, Marcus.
Thanks. We don't really have